Hello, and welcome to the live stream of the Falcon Heavy, which is the second biggest rocket in the world, one we haven't seen so much of recently because the Falcon 9 does so much work. And yeah, we're here in Bremen. I'm, of course, the chief engineer at Astra, which is a student group which is dedicated to trying to um, bring aerospace technology into the learning environment at the university here. And of course, we're trying to build a rocket which will go to space. But of course, one of the places that we can kind of steal some inspiration from is from actual commercial companies that are launching things into space. And of course, SpaceX is quite prolific in the commercial launch industry. And yeah, the Falcon Heavy is definitely a really cool vehicle. It's really cool that it recovers a lot of its pieces, and certainly an inspirational vehicle, being it was the heaviest lift rocket in the world for a couple of years. Of course, with Space Launch System, it's now bumped back to second place, but still definitely cool to watch. So looking forward to seeing it launch again out of the space complex there down in Florida, and it should be a really nice day. So we're having a good chance of weather will be good for us this time. We're about 23 minutes away. You can always take a look at the clock that is counting down in the slides that we're going through here today. Yeah, if you want to know when the launch is coming, it's coming in about 20 minutes. SpaceX should be live in about 10 minutes or so, so we'll be switching to their live stream also and kind of watching along as things happen. And we'll be talking a lot about how the vehicle works and what this mission is all about, how the vehicle recovers itself, and basically what's going on. So hopefully you'll be able to see all the key moments and kind of understand what's happening while this whole launch takes place. And we should hopefully see a really cool rocket launch and hopefully a cool rocket landing as well. So without further ado, let's get into a little bit about how the vehicle actually works and what's going on with this Falcon 9 vehicle and why it's interesting and why it's important in the launch market today. So of course, here we have kind of the main stats of the vehicle. It's kind of basically similar to the Falcon 9, but what you have is you basically have a core, which is basically a Falcon 9, and then you have two Falcon 9 boosters that are strapped to the side of it. And all the engines will light up. So there's 9 engines on each of those cores, so all 27 of them are going to light. And once the side boosters are kind of out of fuel, they're going to be kicked off radially, and then the rest of the Falcon 9 rocket will kind of continue as if it was a Falcon 9 mission. So it's kind of like a boosted Falcon 9. That's how you get to the Falcon 9, or the Falcon Heavy is why it's called that. So a lot of the stats in terms of the dimensions are kind of the same. 70 meters, that's the same height as a Falcon 9. The main diameter of each of those cores is 3.7 meters, again, the same as a Falcon 9. Of course, the takeoff mass is going to be about 3 times more because we have 3 times the boosters. In terms of the payload capacity, it's actually quite incredible. It can get 63 tons all the way to low Earth orbit. Of course, that's in expendable mode, so it would have to expend all parts of it in order to get that. SpaceX will probably never launch in that configuration because, well, why waste a whole rocket? So in the case where you want to reuse stuff, you can only get about 30 to 35 tons into low Earth orbit. But that's still the second biggest rocket, even in the reusable configuration. So pretty incredible. This mission is actually not going to low Earth orbit, though. It's going to geostationary transfer orbit, which is basically an orbit that's useful for a lot of satellites that are doing like communications and stuff. And it's way out there, over 40,000 kilometers away from the Earth's surface. So you have to go into this big elliptical orbit, which takes a lot of energy. So you can't quite move as much payload there. And so if you look at its reusable configuration in that situation, it's only about 12 to 15 tons that it's able to do, which is definitely quite a lot of mass. It's about 2 times what the Ariane 5 can do, which is like one of the workhorse vehicles for getting payloads into a geostationary transfer orbit. So kind of a good comparison there. But also interestingly enough, you can actually get a pretty significant amount of payload to the moon. So this is also a rocket which could potentially be used for some of NASA's plans for getting stuff to the moon. And you can see here they can probably get about 6 to 8 tons if they are still reusing those side boosters. In terms of avoiding GPS COCOM limitations, that's a good question. I have no idea. We actually have a lot of problems with GPS limitations with our rocket that we're building, which will go to space, because you actually can't get GPS signals if your rocket is traveling above 50 kilometers and going faster than, I think it's like 150 meters a second or something, because the American military then thinks you are a missile and then doesn't provide you any data. So I'm not sure how to get around those limitations yet. We're still working on how we're going to actually verify our altitude. But I'm sure when companies are launching satellites and stuff, they have some way to get around these GPS limitations in terms of getting a waiver or something. But as a student group, I have no idea how you might actually manage that. But yeah, just to come back to the Falcon Heavy, we have 2.5 stages on that vehicle, and that was kind of how I was describing where the boosters are going to come off. You almost went to jail for searching for things like that. Well, I don't think anyone's going to jail you, but it's definitely not something that is taken lightly, because, of course, that type of access to the GPS can definitely be used as a weapon. So I guess it's a good thing that they lock those things down, but it's kind of frustrating when you're dealing with amateur rocketry, because, you want to know where your stuff's going. All right, so coming back here to the Falcon 9 here, Falcon Heavy, sorry. Interestingly enough, the boosters that they're going to be using are actually already reused. They were flown back in November on another Falcon Heavy that was launched also for the Space Force. That was on the USSF-44 mission, and now they're going to be the same ones that are going to be flying on this mission, which is USSF67. So it's really good to see these boosters being reused quite quickly. That's only a 75-day turnaround, which is actually, I think, the fastest for a Falcon Heavy. So that's definitely good to see a continued reuse and reflying of this rocket more frequently these days. Where do we buy ammonium perchlorate? That's a good question. You're typically not able to buy it in Germany. This is where we're from, because it's obviously an oxidizer. And those things tend to be more controlled, especially in European countries. But in America, I think you can just buy it. You can just buy it online, and you can start using it to mix rocket fuel. I'm not sure exactly if it's fully free and unregulated, but it's definitely a lot easier there. So a good answer to that would be, I guess, move to America. I don't know. Of course, moving on with the Falcon Heavy here, in terms of the capabilities that it has, I was mentioning how the boosters are going to come back and land, but how are they able to do that? Well, basically, they have all these features that I've shown here. Titanium grid fins are going to be what are enabling it to guide its way back to the launch pad. So it basically takes those out, and they kind of act as wings, kind of almost in a way. And they have an advantage because they can actually deal with the high coming through the aerodynamic forces of the Mach barrier. So when you're flying transonic, they actually tend to be really good. But you'll see them kind of come out. They kind of look like waffles. So if you see those coming out, you'll kind of know what's going on there. They also have these cold gas thruster packs. So you kind of see these like puffs of smoke as those boosters are coming back. And that's when you're way up high in the atmosphere and there's not much atmosphere to actually act on with the grid fins. So you can actually use those grid fins, those cold gas thrusters, to orient the booster when it's not actually in the atmosphere. So that's going to be how it flips around. And then, yeah, of course, it has the landing legs, and you can reignite the engine, and that's basically how it's going to land again. Hi guys, welcome to the live stream. We're just going over some of the Falcon Heavy stuff here and how the vehicle is going to work. So, yeah. Just to go over a little bit about the launch sequence. Basically, what we're going to have here is first we're going to have liftoff. And that's just like how I said before, where there's going to be 9 engines all firing at once. So that's going to be from the core, but also from the side boosters. And yeah, that's going to basically be happening for the first 3 minutes of the flight. And then once those boosters run out of fuel, they're going to be basically ejected towards the sides. But that's not the end of their mission. They're going to be basically reorienting themselves and then flying back to the launch site. And so you're going to see what's called the boost back burn, where they're going to flip over and then kind of use their thrusters to cut off their horizontal velocity so they actually travel back to the launch site. And that's going to be what enables us to see those two boosters actually come back and land down at the launch site again. The core, of course, will continue flying on to orbit. Once the core is out of fuel, it's going to cut off, and you might hear them call it MECO, which is the main engine cutoff. And this is when that booster core is now out of fuel, and then that one's not going to get reused. Actually, it's just going to crash back into the ocean. They've tried to kind of reuse them in the past, but they've never actually successfully landed it on the drone ship and actually reused it. So I think they've kind of given up on that. So yeah, I just saw the SpaceX streams up. Yeah, we'll switch to it in just a second here, just after I get through the staging sequence. Then once the MECO's finished, of course the second stage engine will light up. And then right after that, you'll see the fairings deploy. Although I'm not sure they'll actually show this because, of course, this is a USSF payload, so it's classified. So they probably don't want us to see what's inside. So that part probably won't be shown. We probably won't get to see any video from the actual second stage. So just heads up there. And then finally, of course, you'll see the boosters coming back. They're going to go through a series of burns. They're going to do first a re-entry burn where they light their engines up in the atmosphere to help protect them from the re-entry heating. And then after that, they're going to light the engines up again right before they land, of course, to perform the landing. And really look forward to seeing this because you're going to see both of those boosters kind of landing simultaneously, which is truly an incredible thing to see. All right, let's switch over to the live stream now.
Vehicle that you see there on your screen. Falcon Heavy is essentially 3 Falcon 9 rockets strapped together, which means it can carry much larger payloads, not only to Earth orbit, but to the Moon and Mars as well. Now, like Falcon 9, Falcon Heavy is a 2-stage launch vehicle. Now, the big difference is that Falcon Heavy first stage is comprised of 3 cores, whereas Falcon 9 only has 1. Falcon Heavy has 28 engines in total. Each of these cores has 9 M1D engines, making for a total of 27 engines across all 3 boosters.
So they're describing the Falcon 9 right now.
The 28th engine is a Merlin vacuum engine on the second stage and will power the payload to its final targeted orbit. Now, altogether, the Merlin 1D engines at the base of Falcon Heavy produce 5 million pounds of thrust. That's equal to 18 747s at takeoff. Now, in fact, the engines produce so much power that we don't run them at full thrust all at once until after liftoff. About 2.5 minutes into flight,
I don't think we're 20 seconds ahead of the official live stream. I think your official live stream might be a bit delayed. So maybe refresh the page.
At landing zone 1 and
Usually we hover
landing
about 5 to 10 seconds behind. So.
If successfully recovered, these side boosters will be refurbished and used in a future national security space launch. Now, upon side booster separation, the center core will keep firing for about 90 seconds before shutting down its engines and then perform a standard stage separation from the second stage. We will not be attempting to land our center core today as the mission requires more performance. Now, this means that in order to get our payload to where it needs to go for today's mission, the center core will burn the fuel that we would typically use for recovery. And for those of you looking closely, that is why you don't see any landing legs or griffins on the center core.
I'm not sure about that. To be honest, I'm not really the main avionics person
Once
in the
the
project.
first and second stage separate, the second stage will propel our payload to its intended orbit.
Questions.
At our customer's request, we will not be showing views of stage 2.
I should say that our avionics system is quite
vacuum
simplistic,
engine
though.
on the second
We're
stage
trying
fires
to
up,
keep it as simple as
we'll be
possible.
directing all of our attention to the landing of our side boosters. Now, above the second stage is where our payload is safely enclosed inside of the fairing. That's at the very top of the rocket there on your screen. The fairing protects the payload from aerothermal loads, heating, and contamination during ascent. Now, once we reach the vacuum of space, we will jettison the fairing as the second stage continues on its journey to orbit, and we will be attempting to recover the fairing halves today with our recovery vessel, Bob. Now, as I mentioned earlier...
That's one thing I forgot to mention. They actually are going to try to recover the fairings here as well. The way they do that is basically the fairings can kind of coast back to the launch into the ocean. So they don't do any boost back burn or anything. They just kind of coast back. But because they're so big and so light, the aerodynamics actually slow them down really easily, and they don't really get too heated up as they're coming back. So it's kind of possible to do it without any engines. And in order for them to land, they just basically deploy a drogue parachute that is steerable, and they can basically just land on the ocean very smoothly. And then the boat basically comes and fishes it out of the water. They used to be trying to actually catch them in a net, but that wasn't working so well because, of course, having a large piece of machinery landing like high up on a boat isn't really good for the boat stability and stuff. And the boats actually have a hard time kind of chasing the fairing, because even though it is floating on a parachute, it's still moving forwards at like 20 meters a second, and that's not so fast for a flying thing, but for a boat that's kind of difficult to maneuver around. So in the end, they will actually put them into the ocean. They're not actually caught by the boat anymore. But they make them strong enough so that they can basically withstand the water ingress, I guess. I don't know. But those payload fairings cost like 6 million to make or something. I heard Elon Musk saying that before. So it's good that they actually tried to get them back. Is hydrazine production deprecated in Germany? Well, the upper stage of the Orion module, so like the crew service module on the Orion spacecraft, is actually runs on hydrazine, and that's the part that DLR and Ariane Group were involved in working on. So I would say that hydrazine is not allowed. It's usually a common fuel that's used for space related systems. And so if you're in the official German space agency, which is the DLR, or if you're in Airbus, I mean, that's something that you're going to be working with eventually. So yeah, if you're in the commercial sector, I'd say hydrazine is possible. As amateurs, that's not something you're ever going to see, because that's like super toxic to work with. And if there's like one mistake or one accident, that can cause a lot of damage, I would say. So I hope there's no student groups in the world that are trying to do stuff with hydrazine, because that would be pretty intense. Also, the Dragon capsule uses hydrazine as well. So SpaceX also works with it a little bit. It's a really useful fuel for like attitude control systems and stuff, because all you have to do is just mix it together and then it automatically ignites. So you don't need an igniter system or anything. So it tends to be something that these groups will go towards.
Falcon Heavy rolled out to the pad with the payload at 5:45 a.m. and went vertical about 4.5 hours later. Now, before we began the webcast, the SpaceX launch director,
RP1 load is complete.
So we just heard that the RP1 is
pulled
loaded.
the members of the launch team and got a go for propellant loading and launch. And we're currently loading propellant on all 3 first stage boosters as well as the second stage.
Just to remind, the propellants are liquid oxygen and RP1, and they use that for all the stages. Basically, it's the go-to fuel mix for most commercial systems these days. That liquid oxygen is being cooled down to cryogenic temperatures, and basically they're going to load that right until they're about to go, because that's, of course, boiling off, and you want to keep topping off the tanks. Why did we decide
liquid oxygen is chilled below its...
So why did we decide to use a hybrid system for transcendence? That's actually a good question. We actually originally wanted to try a solid rocket. That was our original idea. But the problem is that doing a solid rocket in Europe is a bit difficult, because whenever... basically, if you want to launch it outside of Germany, which we would have to do, you can't launch a 100-kilometer rocket inside of Germany. That's not possible. There's no launch site that would be able to accommodate that. Basically, that means that you now have to move your rocket to somewhere else in Europe where you can launch. And our launch sites are kind of far away. They'd either be in Sweden or in the UK or in Spain or in Portugal or something. And that means that you have to move that rocket across borders and stuff. And there's a whole bunch of regulations with moving, solid propellant and stuff across borders. anything that could be a propellant or an oxidizer across borders is a real big problem. So due to regulatory things, we decided, okay, maybe we just try to jump those problems by making a hybrid system instead. And we'd seen some success with hybrid systems. There's some groups in Europe that have already worked with them a little bit. Specifically, I would point out High End or Dare. They both have built hybrid systems quite successfully that are able to be high performance. So we thought, well, if they can do it, surely we'll be able to do it as well. So that was kind of the thought pattern that went into it. Yeah, regulations and laws always, get in the way of rocketry, unfortunately. But they're kind of there to protect us a little bit too, because, it keeps you from, blowing your hands off,
Open, the TE can begin to retract away from the vehicle. Now again, a lot will happen in the first 4 minutes of flight. First, we will light the 2 side boosters, followed by
booster lock float is complete.
The center
not
core.
that they're not
40
allowed.
seconds after
It's
liftoff,
just
we
that
will
you can't
decrease
launch them
power
anywhere.
on the 2 side boosters to
So,
prepare for max Q.
you have to
After which
go outside of
we
Germany to
will
launch
throttle
them,
back up
because
to full power
you need a
on the
big
side
area
boosters.
in order to
Now 2 minutes into flight, we will
control where that lands. And the problem is that people
2
live
minutes
everywhere in
into flight,
Germany.
we will again
So
reduce
you're always
thrust
going to
on
be
the 2
threatening
side
somebody's
boosters,
house.
this time to decrease forces on
No one
the
wants to
rocket
have your
structure, as the
rockets
vehicle is now
recovery
much lighter, but
coming
thrust
through
is
their
constant.
coming through
2.5
their roof.
minutes into flight, we will fully turn off the side boosters with booster engine cutoff, or what we call BECO. The pneumatic separation
Center core
system.
lock float complete.
They're calling
Getting
it
good
BECO
calls.
now.
I'm going
So
to
it's not
pause
main engine
for
cutoff,
each one
it's
of
gonna be
those.
booster
The
engine
pneumatic
cutoff.
separation system on the center core then unlocks the 2 side boosters and pushes them away. Now, once we are clear of the side boosters, the center core throttles up to full power until the center core shuts down with main engine cutoff, or what we call MECO, and then separates from the second stage around the 4-minute mark. And as a reminder, we will not be attempting to recover the center core today, as the mission requires more performance. Now, for those of you looking closely, this is why you don't see any landing legs or grid fins on the center core. And from this point on, very similar to a Falcon 9 mission, the side boosters will be making their way back down to Earth for recovery. The fairing will separate, and the second stage will take the USSF67 payload out into space. Now, as a reminder, at the request of our customer, we will not be showing views of the payload, so we will be ending the webcast just after our side
Stage
boosters.
2 lock float complete.
Just after our side boosters make their
so it's
way back
classified,
down
of
to
course.
land on landing zone 1 and landing zone 2, a little after the T+8 minute mark into flight. And as we've mentioned before, launch is hard, and Falcon Heavy is no exception. We are essentially counting down 3 rockets simultaneously, so our team is going to...
Yeah, in terms of the radiation tolerance, we don't really need to have much radiation tolerance because we're only going to be in space for a very brief period of time. So we're kind of just going to use standard avionics equipment. So yeah, maybe it won't work, but I suspect it probably won't be that big of a deal. The radiation difference between 0 and 100 kilometers is not hugely significant, and for the period of time that we're going up, it's just not worth it to harden anything. Yeah, unfortunately, they don't let you. They don't show the spy satellites in the video. I mean, yeah. I don't know if it's actually a spy satellite because it's for
Falcon
Space
Heavy is in
Force.
startup.
Usually if it's spy
And
satellite, that would be
great news,
for like
Falcon Heavy now in
NRA or
startup.
something.
We're now just
Sorry,
waiting
the-
for the final call from the launch director.
Yeah, if it's an NSA satellite, then
director,
it would be
go for
for
launching.
spying. But for Space
And
Force, it's probably
excellent
some
news,
military thing.
all systems are go for launch of Falcon Heavy with USSF67.
T-minus 30 seconds.
If I were a guessing man, I would think it would be something to do with rendezvousing with targets and stuff.
Fifteen seconds.
All right, here we go. The
T-minus
moment
10,
we've been waiting for.
9, 8, 7, 6, 5, 4, 3, 2, 1. Engine full power. And liftoff of
All right, let's go.
USSF67. Go Falcon Heavy. Go Space Force.
I don't think it's the X-37B. That one has never been, they always announce when they're launching that one, so. It's some new secret stuff.
Booster chamber pressures are nominal.
This is looking fantastic. It's really incredible to see all 27 of those engines going, like, honestly.
T plus 40 seconds into flight under the power of 5 million pounds of thrust.
Power and telemetry nominal.
Falcon Heavy is headed to space. Now we did throttle down the engines around the T plus 40 second
Vehicle
mark
supersonic.
It's going through
in
max Q right
preparation
now.
for max Q.
Max Q.
Second.
And great call out there that we have passed through max Q. That's the largest mechanical stress on the vehicle on ascent. And incredible, incredible views there on your screen. Falcon Heavy in flight. Now next events coming up will be booster engine cutoff, or BECO, followed by separation of the side boosters and followed by their side booster boost back burns. And then will be center core main engine
we don't use any
cutoff,
pyro
or
bolts.
what we call MECO.
Our separation system is entirely
And those events coming up here,
with springs
just under a
and
minute
servos
away.
and the gear mechanisms. So
That will be BECO. That's where the side boosters engines will shut down. The center core will push those side boosters away from the vehicle. Then those two side boosters can begin to make their way back down to Earth with their boost back burns.
which, by the way, is actually how these booster engines are going to separate. They don't use pyros
And on
either.
your right-hand screen,
They
you
just
can
use
see
hydraulics.
the views from each of those side boosters.
Whenever you have a pyro, it's always single use. You can always reuse springs or
Really incredible
hydraulics and
views
things like
here.
that.
Again,
So
we will have BECO, side booster, boost back burn, followed by main engine cutoff of the center core here in
you got to
just a few
think like
seconds.
SpaceX. Think about recovery. Think about reuse. So here we go. Wow. Oh, I love this tracking
Side
camera.
booster separation.
Holy. So you can see in the tracking camera, look how they're flipping around. They're going to flip around and they're going to start boosting
Core
back.
booster
You're going to see.
startup.
Incredible views.
Look at that. Oh my God.
Had BECO and separation of the side
This is
boosters. And you
fantastic.
can see on your left-hand screen that the side boosters have lit back up. They are now in their boost back burn,
And you can
making
see
their
how
way
they, like,
back down to Earth.
They slow down in their wake and then they're going to start accelerating in the other direction.
Those side boosters are returning to Florida under the power of 3 engines. That's 3 of the 9 M1D engines.
Honestly, this looks like aliens are landing.
The next up will be
Absolutely
the conclusion. Next up will be the conclusion of those side booster boost back burns, followed by MECO on the center core, as well as stage separation of the center core and the second stage, and then SES1 or second stage engine start 1. Now, as I mentioned previously, per the request of our customer, we won't be showing second stage views after SES1. And additionally, our center core or
I have so
stage
much more
1 is
respect for these
expendable
tracking
today,
cameras
so we will not
because
be
we
attempting
just
to
did
recover
some drop testing
that
about a month
vehicle,
ago,
but
and
we
we
should
tried to
have some
do
great views like we are
tracking,
seeing
and
right now.
we were just tracking from 600 meters, and that was hard.
Should have some great
So I
views
can't
of the
even
side
imagine what it's like to
boosters
track
touching
for
down
like
for
100
landing.
kilometers like this.
Eco.
Stage separation confirmed.
MVAC startup.
And excellent views. We had the
Stage 1 FTSSA has safed.
We did have the shutdown of the
Acquisition
boost
signal.
back burn. We did have the shutdown of the boost back burns on the side boosters as well
Fortunately,
as the
these
MECO on
cameras
the
are a
center
bit
core and stage
suited over.
separation.
I hope that the entry will clean them off a little bit.
We are waiting for confirmation of a call out of the fairing separation.
But you can see that there's
All vehicles
definitely
are
soot
following
on the
nominal
camera.
trajectories.
But at least they have this incredible tracking shot. Like, my goodness. So basically, those boosters are gonna, they basically, they flew up, and then when they separated, they were still going like towards orbit. So they had to boost back, and they kind of do this like weird loop back, but they're still going up, and they kind of do this weird parabolic arc back to the launch site. So it's kind of like this weird like,
So currently
loopy
stage
loop
2
with the
is
arc.
still making its way to its targeted drop-off orbit, while the side boosters are making their way back down to land.
So we might
And
see
these
their
side
re-entry
boosters
burn here in a
have
second.
another burn coming up. That will be the entry burn. That will be 3 of 9 M1D engines reigniting. That helps to slow the boosters down in
And it might just clean
preparation
off the cameras too.
or as they
We'll
re-enter
see.
the Earth's atmosphere.
We are ordering PCBs from China.
We got
I
some
believe they
views
come
here
from China.
from those side boosters there on your screen. Now, at the time of separation, the side boosters were traveling slow enough to turn around and make their way back to land, to our side-by-side landing pads. If we have successful landings today, we'll mark the 163rd and 164th landing of an orbital-class rocket. As I mentioned earlier, the center core will be expendable,
I feel like they should stop
and we are not
tilting.
attempting to recover it today.
I mean, my goodness. Here we go. There's the reignition.
Side core entry burn startup.
And there you can see on your screen the entry burns.
And you can
for
see
these
they're a
side
little
boosters
bit
have
out of
begun.
sync.
They're just about 12 seconds long.
This is by design, so don't worry.
FTS has saved, and MY FTS has saved.
They actually don't want them to come in exactly
and
the same
entry
time.
burns for
Oh,
both
finally.
side boosters
Camera
have
cleared
now
right up.
concluded. Now, next up will be the final burn for each of these side boosters. That is the landing burn.
I think it was the
It is
cold
just a
gas thruster
single
that
engine
cleared it.
burn, the center E9 engine. Each one of these M1D engines have about 190,000 pounds of thrust. So that is enough to slow the vehicle down just in time for landing. And you could see the coast of Florida in the background.
Side boosters are transonic.
And this is where you're going to see those grid fins start to
Now, that
actuate. They're the
landing
little
burn
waffle things
coming
sticking
up
out.
here in just about 20 seconds
Kind
or
of start
so.
to see them move back and forth because they're going to start doing their job
Landing
to fly
burn
those
will
boosters
last
back.
about 20 seconds long. Again, we are scheduled to land on landing zone 1 and landing
Booster
zone 2.
landing burn.
Oh, you can see the other one in the other one's
There are those
camera.
landing burns have
Oh, this
begun
is
on the
incredible.
side boosters, so let's watch as they touch down.
Stage 2 is on thermal guidance. Stage 2 FTS is saved.
Here we go.
Booster
Looks
landing lane
good.
deployed.
That's one down.
And what an incredible sight to
number two.
see as we watch the
Both
side
down,
boosters
landed.
touch down for landing. That confirms successful landing of both Falcon Heavy side boosters on landing zone
the
1
second one
and
got a little
landing
bit
zone
occluded in
2.
the smoke.
Now with these two side boosters, this marks the 163rd
Okay, all right.
and
Successful mission, guys.
164th overall successful landing of an orbital class rocket. It's also the 25th landing on landing zone 1 and the 6th landing on landing zone
shutdown.
2. And with successful confirmation of our side boosters landing, that will bring today's webcast to
Nominal
a
orbit
close.
insertion.
Now, we'd like to thank the United States Space Force for entrusting us
All
with
right.
today's mission.
Looks like a good day for SpaceX. I'd love to see those two boosters come back to the pad like that. It's always cool to see, like, in the cameras on the vehicles, you can actually like see the other rocket in its camera, and you can see it turning its engine on and everything. Yeah, it's a wild world we live in. Anyways, so that's it for the SpaceX launch. Maybe I can get to a couple of you guys' questions in the last seconds here. Yeah, in terms of the PCBs from China, yes, we do order PCBs from China. But the way it works is basically you kind of like make your drawing of what you want your circuit to be, and then you send it, and then basically someone can print it for you. Yeah, if you're doing crazy stuff that's like something you might want to protect with a patent or something, maybe don't go to China because yeah, they might, steal your stuff or whatever. That's certainly a problem that's always like, there for commercial companies. But we're a student group, and we're not doing anything too crazy. Like, we just are designing a circuit that will basically control our recovery system. So activate the separation system and activate the parachute. And we have a couple of sensors on board that we're trying to, of course, get data from. But like, this is nothing that's proprietary or anything. Like, we're not doing anything revolutionary in the avionics world, I don't think. So getting them from China is not a big deal. It could be a big deal in terms of like, how shall I say, politics or something, or like economics, because there have been slowdowns with stuff coming from China due to coronavirus. Apparently it's starting to go big there again, and getting electronics is becoming more difficult. Yeah, but yeah, that's just some stuff with Transcendence. Don't worry about that, we'll figure it out. Anyways, guys, it's been great to have you, and I'm glad to see that this rocket launch has been a success, at least to this point, for the unclassified part. Stay tuned for SpaceX's on their Twitter feed or something if you want to see what happens with the actual USSF67 mission. It's going to be flying for a while because, of course, it has to go into low Earth orbit, and then it's going to be doing a burn into geostationary transfer orbit. I think they're also going to be doing some burns up at a geostationary orbit to boost that satellite a little bit more, which is another feature of the Falcon 9. So yeah, I'm not really sure exactly if they will be announcing that stuff, because that's where it gets more into the classified zone. So yeah, if you want to contact us via email, you can always go to our website. There is the Astra email is going to be there on the contact page. So I would highly recommend that you go there if you want to ask questions or whatever. If you want to ask the channel questions, you can also, I think, email the channel. Although I'm not entirely certain what the channel's email is. I assume it's just astra-bremen at gmail.com. But you can try that one, see if it works. I don't know. Yeah, if you have any questions, of course, just ask them as you feel. If you want to write the email to the Astra channel, yeah, astra-bremen at gmail.com, I believe is the Astra email. I answer all of them if they come. But you can also just ask questions on our videos. We have lots of videos about our rocket and stuff, and some of the questions might be answered there. So maybe check those out, see what Astra is up to there. And if you have any comments or anything, always leave comments on the videos, whatever. We respond to them relatively frequently and try to answer people's questions. And sometimes if you have a really crazy question, it might turn into a video itself. So definitely feel free to ask all your questions. Anyways, guys, that's it for us here tonight. And I hope that you enjoyed the Falcon Heavy launch. And I hope that you'll join us in the next one. I hope you continue to expand your horizons.